Hello. Yeah, let's see. You should see the desktop and you should hear me by now. Sorry I'm late. I was writing something and lost track of time. Let me see. Let me try to get okay. Try to get the chat window up. Okay. So everybody, can you hear me? Is everything seem okay?
Yep.
Yeah, okay. Thanks. All right. Okay. Okay. So today we're gonna talk a little bit more about aspect ratios and view volumes. Okay. And then on Thursday, we'll start another render, which is going to be one of the key ideas is we're going to start the linear algebra part of the course. We're going to start using matrices to move things around. It's a big part of computer graphics. And that'll take up a lot of the rest of the semester. Okay, so let me download this and this. Okay, and the other day we talked about how aspect ratio affects things. Okay, and I think today we want to talk more about how the talk more about the view volume aspect of this. We've been emphasizing the aspect ratio more than the view volume so far. Okay, and remember the difference was if you look at one of these pictures of what projection looks like, we've been emphasizing the aspect ratio of this of this projection window here, the image frame, the image rectangle. We've been emphasizing the aspect ratio of that. Okay. Now, but when the aspect ratio of that determines the aspect ratio of the whole view volume, we want to start talking a little bit more about the view volume as a whole, the whole view volume, and how the render handles it. How does the render deal with different shapes of view volumes? Okay, so it's real important to when you have, remember our point of view was that we had a source aspect ratio and a destination aspect ratio. If you see, like here, this is the source aspect ratio. This is the destination aspect ratio. Here they're the same. So the little figure, when it gets drawn here, isn't distorted. But if this aspect ratio should change, but this one stays fixed, or if this one should change and this one stays fixed, then you get mismatched aspect ratios. Okay, the aspect ratio of the source doesn't have to match the aspect ratio of the destination. I couldn't find a nice picture of that. The books aren't very good at describing this idea. They kind of just ignore it, even though it causes a lot of confusion, and it's not that hard to explain. I wish people. I haven't had time to draw my own pictures. They're kind of hard to draw, but you want the idea that this one and this one don't have to match, and then picture like if they had a circle here and this didn't match, the circle gets distorted to be an oval. Okay, and we saw that with the homework assignment 3. When you resize. Uh, Homework assignment 3 was a good source of that. The demo program for that one. One way to think about what's happening here is when you run the demo program, okay, in your mind, what's happening here is what we're seeing is this picture here. We don't see this. What we're seeing is this. And when I do this, I didn't change anything on this side of the picture. Nothing got changed over here. I only changed this thing, and that causes distortion. Okay. Okay. So what I'm doing here now is I'm manipulating the frame buffer. I'm changing the size of the frame buffer, I'm giving the frame buffer different sizes, but I didn't do anything to the geometry over here in camera space. The camera's still looking at a picture with a circle over here, a square next to it, a square in the center, a square in the lower left-hand corner, and a diamond in the lower right-hand corner. That's this. Nothing over here has changed. Now, when I do this, where did that change happen? If you think in terms of this picture, what am I doing when I do that? What is this doing over here in camera space?
Changing the object back on the camera plane and not the view plane?
Well, it's doing both because it's actually moving it in the camera plane over here, right? So I'm grabbing it over in here, but then your program would project it back to here to figure. Well, my mouse clicks on a place in here. See, I click down here, so the mouse click would be here. Your program did a little bit of algebra to compute where the mouse click was in this window, and it noticed that it was inside of a circle. Okay. Then when the mouse dragged over here, your program did a little bit of algebra and moved that circle over here. It didn't move an ellipse, it moved a circle. But then the circle got projected back over here into an ellipse. Okay. It's real important that you can get like a real good sense of the literally what you're doing when you run programs like this. Yeah. So we have this view volume in camera space, which is created by the renderer. It's an abstract idea, but it's created by the renderer. Okay. And the renderer thinks there's a circle here and a square here. And then the renderer projects it to a frame buffer, which we see here. You click on the frame buffer. Okay. When you clicked on the frame buffer, your program did algebra to translate that to a point over here. Over here, it realized that that point was inside of a circle, and it moved the circle. But then the circle got rendered back over to here as that oval, shifted over. Like this guy is still a square sitting there. And this guy is a square right at the center. And this would move that square up. But what I did is I clicked over here. Your program translated it to a click over here, realized it was in the square, figured out how much to move the square up, then the square got rendered back over here as a rectangle because this window doesn't have the same aspect ratio of this one. Okay. Now, in this render, we have no ability to change the aspect ratio of this one. See, the renderer, this was done in renderer 2. And up to renderer 5, we have no way of changing this picture here. This thing goes from, in our case, it goes from left, top, near are all 1, 1, 1, 1, 1, 1. You go 1 unit over, 1 unit up, 1 unit down, 1 unit to the right. So this is a square of side length 2 and 2 because it goes. This corner here would be 1, 1. This corner here would be 1, negative 1. This corner here is negative 1, negative 1. This corner here is negative 1, 1. Okay, so everything has got everything's at the corners where you have plus or minus 1. So all the corners are plus or minus 1. This renderer can't change that. Okay, but we can change this thing just by grabbing this and doing that. Okay, the render, when it projects all this stuff over to here, it distorts things. Stuff, what was 1 unit across here becomes maybe more than 1 unit across here because I'm grabbing this and stretching it horizontally like this. So now 1 unit going this way becomes more than 1 unit going this way. But if I'm stretching it horizontally, I'm not changing the vertical direction. So 1 unit vertically stays 1 unit vertically. So you think this thing becomes elongated because it has to stretch. What was 2 units across here has to get stretched to way more than that across here. Okay, if you go back to the start, this is 2 units across, and this is 2 units across here. The origin's right there, and this is plus 1, negative 1. +1, -1. But now this is still +1, -1, but who knows? This is way more than 1 over here and way more than 1 over here. Well, it isn't. It's still 1, -1 here. So you just have to stretch those pixels farther across. Yeah. From the point of view, it's still -1 on this edge, +1 on this edge. They're just being stretched over a longer distance in the frame buffer. So there has to be more pixels going across this way per unit than there are pixels going across this way per unit. It started out with the same number of pixels horizontally per unit and vertically per unit. Now there's going to be way more, there's going to be way more pixels per unit this way. So this is still 1 unit from the center to the edge is 1 unit, but there's a lot more pixels now. So things get distorted. Okay. Now, the renderer 6 lets us, if we wanted to, change this this aspect ratio to match what's over here. And that's one possibility of what you can do. When somebody changes this aspect ratio, you could go back and have the renderer go back and get this one to match this one. Okay, but there's other choices you can make also. Let's see. Let me try drawing a picture. You start with a source rectangle, and over here we'll have destination rectangles. Okay, in our case, source is this rectangle, destination is this rectangle. In the examples we did last week, the source was a photograph, and the destination was the window you displayed the photograph in. That's when we played with Irfan View and Photo Viewer and web browsers. In those cases, I used the picture as the source, which in the picture had its natural aspect ratio. But then when you displayed it in a browser window, the browser window could be different aspect ratios. Now the source is the image rectangle over here, the front of the view volume, and the destination is the frame buffer over here. Okay. Now you can end up with, imagine, where's my rectangles? Here's a nearly square source, and here's a very that's a landscape mode. Okay. Now, suppose you have to display that source in that destination. Okay. One possibility is just to take this guy and center him in this, and just not use all of this. Okay. One possibility, remember, you could just take this guy and center him in there and not use all this space. What name did we give to that? Does anybody remember what name we gave that? You take this one, put it in here. Don't distort it, but then you have to leave empty space.
Letterboxing?
Yeah, that's the letterboxing. Okay. Okay. Now, another possibility is we do another destination. Okay, now this destination's, okay, it's still in landscape mode. Okay. Okay. Now notice that this one, the height of this one was about the same as the height of this one. This one has got a bigger height than that one. Okay. Oh, okay. Actually, go back. This one, when you put it in this one, you could just stretch it. You could take this upper left-hand corner and put it here, and take this lower right-hand corner and put it there. So you would just stretch this like it was a piece of rubber over that rectangle. What would that do? What do we call that?
Distortion.
Yeah, that's when you get the circles looking like, that's when you would get a circle in here. Yeah. Then you would get a circle in here as an oval in here. Okay. If you just took this and copied it into here, you wouldn't distort it, but you'd have empty space. Okay. Now this one's a little bit more complicated. I want to take this guy and put him inside here. Okay. One possibility is I take him and I put him in here in the middle. Well, I can take him and just plop him right there. Okay. That would be letterboxing. I just take him and I plop him in there, leave a bunch of empty space. That's letterboxing without changing the size of this guy. Okay. But I might do something else. I might say, I could grow this rectangle and still keep its aspect ratio. Notice that right now I'm saying keep it the same size and put it in here, but don't do anything. Just put it in here with the same size. Okay. But what if I decide I'm willing to grow this guy, enlarge him? I could make him say that big and keep the same aspect ratio, and then the circle would just become larger. Whoops. Okay. That's still letterboxing. That's letterboxing with scaling. I would scale him larger, as large as I could make him, so that he keeps his aspect ratio, but he leaves some unused space here. Okay, so that's letterboxing with scaling. Okay. Now another possibility is I might just do the distortion. I could just take this guy, take the upper left-hand corner here, put it in the upper left-hand corner here, take the lower right-hand corner here, put it in the lower right-hand corner here, and just stretch this guy over here. That would distort it. Now, let me show you a weird thing you could do. When I letterboxed, I would make the rectangle still a square. I would keep the aspect ratio as big as possible, but keep the aspect ratio the same and make it as big as possible. What if I decided I would do the following? Notice that that's a square.
Cropping.
Yes. Yeah. See, notice that now it's a square. Whoops. And here's the circle. But what do I have to do now? I have to crop it. I wouldn't see this part of the picture up here. This part of the picture here, I don't know if I can shade a part of a picture. You know, this part. See, that part of the picture would have to be cropped off. Okay, so the destination rectangle is the destination rectangle is this white one. This is the source rectangle. It's a square. I make a big square that just fits on the left and right edges here, and it extends off the top and bottom, and then I crop this. Okay, that's one of my possible choices. Okay, and we saw that you can write code that does that way. It's just one of the choices you can do. Now, what's the advantage of why might you want to do cropping instead of the other ones? Distorting does distorting. So you might say you don't like it because it changes the shape of this. A circle looks like an oval. Okay. What happened when we did the letterboxing? What was the slight disadvantage to letterboxing?
The leftover.
Yeah, you're wasting space. You've got leftover space. You've got the view. You've got the frame buffer. You're not using all of it. So in a sense, so now what's the advantage here? There's no distortion of shape. You're using the maximum amount of area, but the thing you're sacrificing is part of the picture is gone.
Does this kind of do a little foreshortening though? Like making...
No, because it's the exact same image that appeared here.
Okay.
Yeah, it's just this picture enlarged and then chopped off at the top and bottom. Okay, so this picture just got enlarged, no distortion at all, nothing that would do anything that would foreshorten or distort. So this picture got enlarged, but then it was overflowed the destination rectangle, so you cut off the top and bottom. Okay, right? Now, here's another example of the same kind of thing. let me suppose that the destination rectangle, so here's another destination rectangle. Suppose the destination rectangle now is portrait mode. So the destination rectangle is in portrait mode, okay? Now I can do the same kind of thing. I could take the source and just plop him in the middle here, the exact same size, okay? So no distortion at all, even no scaling, just plop them in there. Then lots of letterboxing, lots of empty space around here. I could say, well, make him grow to just, now if he's a square, he grows till he straddles the width, okay? And that leaves space empty at the top and bottom. Now you don't have to center them if you don't want to. When you do letterboxing, usually you center with the unused space evenly divided between the two ends. But here, I'm going to leave the unused space. I'm going to leave this unused space different than this one, okay? And then the circle would be inside, okay, but undistorted. Okay. Now, what's interesting, what happens here if I decide to crop? If I decide to crop here, here would be the square. I think the square would be like this. Is that a square? Yeah, that looks pretty, okay. There's the square. Actually, I think it'd be good if I used a different color. Okay. Okay, so I extend this as a square. I'm not going to waste it, but now I have to, and then the circle will be not distorted. The circle will be in here. But now I have to crop off over here. I thought I used a different color. So I crop off that part. Okay. Now that's a circle inside here. Yeah. So I've used up all the space in the viewport. Yeah. But I have to crop off part of the image. So the image was scaled to overflow this thing, but to be using as much space as possible. But that caused there to be some overflow on the left and right. So you cropped on the left and the right. Okay, notice that if you take a square and put it in portrait mode and crop it, you crop on the left and right. If you take a square and you put it in landscape mode and you crop it, you'll crop on the top and the bottom. Okay, so those are the strategies we can use. Okay, now those strategies involve, okay, now the user chooses the destination shape. In our case with the renderer, in the case of the render, the user chooses this shape. I don't know if I still have that program running. Yeah, see the user chooses the destination shape. Okay, so the user changes this. Our code would have to change this if it wanted to. If our code wanted to match this to this, it would be our code that has to do that. Our code responds to what the user does, but the user is manipulating the frame buffer, and then it's up to our code to decide how it wants to do it. Which one of these things over here does it want to do? Does it want to just take this window and just center it over here without making it grow or shrink? Does it want to take this window and sort of keep the right aspect ratio from over here, but sort of maximize how it fits into this window with no cropping, just letterboxing? Yeah. So no scaling and no crop. It could just take this and put it in here with no scaling and letterboxing. It could take this and put it in here with scaling and letterboxing, or it could put this in here with scaling and cropping. Right now, these pictures are scaling and cropping. Okay, there's no scaling and letterboxing. There's the idea. That would be this guy. The source gets put in the destination with no scaling and letterboxing. Okay. And over here, we could have, let's see, if we scaled it and letterboxed it, I don't have enough room now. You could not scale it. You could scale it and letterbox it. You could scale it and crop it. Okay. So you get all these different choices. And there's actually demos of all those choices in that one folder. If you go to the Render 6 folder, there's almost every possible combination there, of letterboxing, cropping. One does distorting, one does letterboxing, one does cropping, and the other one does the scrolling, where you can scroll. This one does scrolling, where you can scroll. Okay. Oh, because that's another. When you look at these pictures, like here, when you see that they're like, take this one here, you've cut this off, you've cut this part here off, and you cut this part here off. But you don't actually have to really cut them off. You could put a little scroll bar down at the bottom, and you could actually let the user just scroll left and right, so they could shift this picture to the right and see more of this side of the circle, while this side of the circle goes off the edge. Or they could scroll left and see this side of the circle. That's called panning or scrolling. So you're cropping, but you can let the user okay. Now watch. Okay, the window's cropped. But now I go down here and I can let the user pan back and forth. Okay, so I have cropped it, but I'm still leaving it for them. So that's exactly this picture here. See, the view window is tall and narrow. The circle has been cropped off, but I can let the user slide and see the whole thing. I mean, my program has to do that. My program has to do that. Now, this is done by going back to the this is done by actually going back over here and moving the window around over here. As the person changes their scroll bar over here, I have to go over here and move things around inside of that window so that the part of the circle I want to see is centered in the window. Because my view volume can't move around. My view volume is stuck in one place. Now we're going to fix that in the newer render, but in this older render, the view volume was stuck in one place. So when I wanted to like do this, the only way to really do it was to actually take this view window and take the geometry, the picture, and move it around and make it slide back and forth inside of that little view window. So there's a little view window here that gets sent to this view window. Like, well, this thing here is being sent to this thing here, and then you have to kind of shift what's seen in it. You have to move what's seen in it. Okay? But the idea here is that if you think of it in terms of this picture, you've cropped it, but then you can put a slider down here and let the user slide what part is visible inside that window there. And similarly here, you could put a scroll bar here and you could let the user take this. Essentially, you can think of it as two ways. You can think of this window as sliding up and down over the picture, or you could think of the picture as sliding up and down behind the view window. And some people like to think of it one way, and some people like to think of it the other way. Again, you can think of this view window as fixed, and behind it, the circle is moving up and down, so you can see different parts of the circle. Or you could think of the circle as fixed, and this window slides up and down in that box to show you more and more of the picture. Same over here. You could think of the white box as being slid left and right, so you can see more of the picture. or you could think of the picture behind the window moving left and right so you could see more of the circle from through the window. Now over here you can see what, it's probably better to think of the window as being fixed and what's behind it is moving back and forth, because here the window stays fixed. See, it's in a sense, it's really what's behind the window that's moving left and right. But logically, it doesn't matter which way you do it. When you write the code, you could think of it literally it's either way. You could think of that window as being moved left and right in front of the circle, or you could think of the circle as being behind the window and the circle's moving left and right to show you different parts of the circle. Okay, so these are the kind of things that everybody has to work. Now, this is not, I mentioned the other day, this is not unique to 3D graphics. This is anytime you're going to do any kind of a GUI, you're going to have to worry about this stuff. You're always worried about what view you have of something, whether it's a picture or text or a table or a graph. You've got views of things, and you have to be able to, people are going to do things like this, change the aspect ratio of your views. They resize their browser window. You resize a browser window. Notice that what the browser is doing the similar things here. What's it doing here? What's the real issue when I change, in this case, something similar but not quite exactly the same thing. When I change the destination window, what's the browser doing in the source? And what is the source? Try to find the common, computer science is about finding patterns in problems. And there's an amazing amount, if you think of things the right way, you can actually say these three things that look completely different to me are actually the same thing. And this is a very similar idea. It's almost, but not quite, but really close to what we're talking about over here. The destination is the browser window. What's the source and what's the browser doing to get things to match up? Oh, I'm sorry. Do you guys see me doing this?
No.
Stupid Zoom thing. What I'm doing is I'm taking the browser window and just, you see it like there's, resize it, resize it, resize it.
There, it did it.
How long does it take for it to catch up with what I'm doing? Like I'm moving it, then I stop.
Yeah, I think you need to leave it stopped for a little bit longer of a pause.
Okay. Oh, I went back and looked at the video from last week. It really is. Yeah. I was talking with my son about it. We thought that was nuts. We just could not even imagine that Zoom would do something like that. We can't even figure out how it does something like that. Okay. Can you see what I mean? What's the issue I'm dealing with here?
Okay. Yeah, you see different information each time. So.
Yeah, but what is it doing?
Oh, that means it's cropping?
No.
It's doing a combination.
Well, yeah, but what's the word for here? What is the source here? The destination is this window. What's the source? Very important idea. This one comes up a lot. I've got a destination window, a viewport, and I've got a source. The source is not quite something as geometric as these guys. What is the source?
Browser engine.
Pardon me? No, browser engine is the renderer. That's the tool. That's the thing that's doing what I want. The browser is the renderer. I mean, many people refer to browsers as renderers. If you start reading the literature, you'll see that the people who do this stuff almost always refer to their browser as the renderer.
No, I'm talking about the engine, like WebKit or Blink.
That's the renderer. That's the engine is the renderer. Go read up. Here, let me show you. No, that's not. See, Blink, rendering engine, the Chrome. See, Blink is the renderer. It's literally the word they use. Some people call it a browser engine, but notice the Chromium people themselves, see, Wikipedia refers to it as a browser engine. The Chromium people refer to it as a rendering engine, okay? Yeah, and if you go here to Blink, if you go to here, there's a link on Wikipedia for a whole bunch of different, these are a whole bunch of different browser engines, but they actually refer to themselves as browser renderers, okay? So so like right now, I'm changing the destination. I'm changing the destination, and the renderer is responding to me changing the destination. What's the source? Yeah, somebody put it in the chat. What's the source? The HTML. It's not really the HTML is not what I would quite say, because the HTML is just what's inside the HTML.
Body.
Pardon me?
The body.
The body. And what's the body? You're trying. Yeah. What
It's-
is? Okay. Let me show you another example. There's no HTML here. Oh, God. Okay. There's no HTML. What did I open up? I'm reading a. What are you looking at here? Java files, Java source file, and I'm looking at it in a text editor. What's the destination? From our point of view, what is the destination rectangle?
The text box.
The text box of the text editor. Okay. What's the source?
The text file.
Yes, the text file, the text itself. What's Textpad doing as I resize?
Cropping.
Cropping. Okay, it's cropping. The source is a body of text. The destination is this text box. And as I resize the text box, the browser, but it's actually doing, it's cropping with what?
Scrolling.
Yes. So it's like this example here. Cropping with scrolling. Gee, think of it. A text editor. Now, think of it. Does that make sense? How in the world can you say that a text editor is like a graphics program? What are they ultimately both doing?
Drawing pixels.
Drawing pixels. Yes, that's why they refer to as that's why Google refers to their browser engine as a renderer. Its job is to draw pixels. Okay, right? Now go back to the browser. Tell me what the browser was doing. This is the destination. The destination is this browser window. What's the source? I don't think the source is HTML. To me, the source is what? What do you think I think the source is? Take one step back from the HTML. For example, I may have written this thing in Markdown. I may not have even written it in text in HTML. What am I really worried about?
The web page.
The text itself, the paragraphs, okay? The paragraphs. What's the browser doing differently than Textpad? Textpad, when I resize, cropped and gave me scroll bars. Textpad cropped and gave me scroll bars. The browser is doing what? Now there's a vertical scroll bar, okay. But what about horizontally?
It just word wraps.
Yeah, it flows the text. It word wraps the text. There's no easy analogy to the word wrapping in the graphics world. Okay, the browser has an option in the text world that we don't have in the graphics world. It's a little bit like distorting. Notice that you can kind of think of it as what? Okay, think about when you distort here, a circle becomes an ellipse. So it changes its length. In a sense, this is like the distorting thing. What's that paragraph? Look at the paragraph under the word mission. What's its shape right now?
3 lines.
No, the paragraph under mission.
The rectangle.
What?
The rectangle.
A very
Long rectangle.
yes.
Very
Now,
long.
same paragraph. What's its shape now?
Portrait.
Portrait. See, the shape of the paragraph changed. So that's kind of like what?
Distortion.
Yeah, it's kind of like a distortion thing. Flowing text is a little bit analogous to distortion in the graphics world. Okay. Now, believe me, the people doing this think this way. There is a commonality because it is a render. We're painting pixels. We've got to work with shapes. In this case, there's the shape. Now, for example, that shape is not good for a paragraph. That's a distortion. Does anybody know what's wrong with that shape? This is really not good. A typographer would really just scream at whoever did this. What's wrong with it?
Too many words in one line.
Yeah, it's hard to read. You have to almost turn your head. There's a rule about web pages and a rule about readability. You should be able to read a line without rotating your head. Now, that seems normal to you. When you read books, that's the way they're all written. But if you look at a lot of people's websites, when you maximize your browser screen and you do this, you'll find that to read from one end to the other end of a sentence, you sometimes actually have to rotate your head a little bit. Or you certainly have to rotate your eyes a lot. You actually, in a well-rendered web page, you shouldn't even be moving your eyes. The text is not supposed to be much more than about this wide. If you go read about usability, you'll learn that that's about the width that a paragraph should be, even maybe a little less than that. Okay. And if you go to really well-designed websites, you'll notice that even when somebody maximizes the screen, the text never gets any wider than that. Because now your eye can look forward and your eyeball doesn't have to move and your eyeball can read the lines. Okay. So this is too much distortion. In the case of like over here, that would be too much distortion. What they really should be doing is doing some sort of letterboxing in text. And that's what they literally, they would take this thing and turn it into like 3 lines of about this length and leave a lot of empty space on the left and a lot of empty space on the right. They would letterbox the text, okay? And the people designing render engines think a lot in these ways. Source, destination. The aspect ratio of the source, there's some sort of ideal. In the case of text, you have an ideal sense of what the source is. The source would be this paragraph formatted perfectly. Okay, so there'd be this ideal notion of what the source is of a perfectly formatted paragraph. And then you've got your destination window, which is the user maximizing their browser window or scrunching their browser window. And then you have to render this, you have to do some sort of mapping from the source to the destination. And you have lots of choices. You know, the Textpad does cropping. Textpad just says, here's my ideal layout, and I'm going to hold it. There's my ideal layout of the text, and I'm not going to change it. If the user scrunches his window, the user has to put up with scrolling because the text editor is not going to do that. Now, you can tell Textpad to flow the text if you want. I forget how. Let's see. Yeah, there it is. See, now I switched Textpad into a different mode. See the little reflow button here up here? There's the little reflow button. So Textpad can go into reflow mode, like the browser was in, or Textpad can go into cropping mode. Okay? Notice that there's a lot of what we're dealing with. There's a commonality. There's fundamental ideas lying behind lots of what seem to be just different ideas here. Like reflowing text is just really a form of it's a form of this thing: destination, source, and destination. Here we're doing rectangles and circles. Over here you're doing text.
I have a quick question.
Sure.
So if you do the right click and do the developer information, does the shape that it shows change too, or does it stay?
I don't know. Okay, right click where?
Anywhere on the, like when normally if you have a web page open or something, you can right click.
Web page. Okay, so you're talking about in the browser now, right?
Yes, yes.
Okay, in the browser.
If you right click on it somewhere and pick, I don't know if your computer does it, but mine does. You can like get the developer information, and it'll show you like the shape of the page or something. Do you know what I'm talking about?
Oh, I mean,
on Windows, you might have to do
this?
something. Yeah, usually it'll show a picture of the shape of it.
Yeah.
I was curious if that changes when you reshape the page.
Oh, that okay. Yeah, let's see. There's a nice. Let's see. Let's see. I'm trying to remember. Yeah, where?
Oh, I saw it for a second when you were scrolling through something.
Pardon me?
I thought I saw it for a second in the middle part.
I don't. I'm trying to remember what you. Let's see where.
I'm new to all that stuff, so I don't really know where it is. But
oh, I can't remember now where. Yeah, you do get a view of rectangles sitting inside of rectangles. That's the cascading style sheet. Yeah, it's very related to this.
Yeah. So does when you shrink the page, does that image change as well? That's what I was kind of.
I think it depends on what you're looking at, but that's a real good point. The cascading style sheet is a model of boxes inside of boxes. If you read about how cascading style sheets work, it's a model of boxes inside of boxes. So in a sense, cascading style sheet kind of works like this. Here's a box, and then there's another, then there's a box inside of it, and then there's a box inside of it, and there's another box. And these boxes are paragraphs and pictures, and there's boxes inside of boxes. And they kind of, then when you change this outer box, what happens to these boxes inside here?
Yep.
Change, like this outer box would represent the web page. And this might represent a paragraph and a picture and another paragraph and another picture and a heading. And then now you change the shape of this box, the outer one. What do you think can happen to the inner boxes?
Depends on the CSS rules.
Right. So what are possibilities?
Flow is they could
Flow,
then.
yeah. Like if I widen this one here, this box might flow up to there. What's another possibility? Besides flowing, you could do what?
Cropping.
Cropping. You know, if I took this box and cut it over to here, it would just chop off these boxes. And And yeah, I think the browser will show you what's happening depending on what rules you set in the CSS. Okay, so now see this paragraph here? That's a box. See how it's a box when I highlight it? Then see how the box has changed shape? See, that's a box. See how the box has changed shape? Now it's long and narrow. That to the browser, that paragraph is a box. The paragraph sits inside of what I'll call a bounding box. And then then inside that bounding box is the flow of the text. So the text will be inside that box. You know, the lines of text will be inside. The lines of text will be inside here. Inside here would be lines of, I can't figure out how this thing works. You know, you got lines of text inside of a box. That's how the browser thinks of it. Then if you change this thing here, all these boxes have to reflow and do things. Then after these boxes have reflowed, then you have to decide what to do with the text inside that box. Like if you grow this box, maybe all these boxes get larger. Then maybe the text will reflow in one way. If you slide this outer box and you crop these things, that will affect what you do to the text inside that box. The cascading style sheet model is boxes inside of boxes inside of boxes. And text lives inside of a box. And then this would be another, like here, that bullet item would be one box. That bullet item would be another box. That bullet item would be another box. The bullet list would be another box. So you'd have a box that's the bullet list holding a box that is each bullet item, which holds a box which holds the text in the bullet item. Okay, boxes inside of, that's called the box model. They gave it a real creative name. They called it the box model. And these are the pictures you see inside the browser. See, if you look in the right, if somewhere in the browser, does anybody remember, I'm trying, somewhere in the browser, if you go and you look in the right place.
If you click at the top left of the developer tools, top left, there's a little cursor icon.
This one? Is it this one?
Yeah, and you select, you click it, and then you select, there you go. And then you scroll down, you can see the box model.
Yeah, there's the box model. Okay, there it is. See, boxes inside of boxes inside of boxes. And those boxes all have aspect ratios, and they start manipulating weird things with, see, as you notice, if I move around here, you see different highlighting over here. Okay. So the renderer is basically working with, very much like what we're doing here. The renderer is working with boxes. In our case, there's only 2 boxes. In our case, we're down to, what are the 2 boxes? We only have 2 boxes. What do you think I mean by our 2 boxes?
The image plane and the,
which I'm calling the source here.
Yeah,
and
the destination.
Oh, actually, we could say we have 3 boxes. We could say we have 3 boxes, because yeah, there's the
J-frame.
There's the image plane. That's a box. Now look over here. Look, see how there's like 2 boxes here? I think I should, yeah. He calls them computer screen and computer window. But think of our way of doing it. This outer box could be what, and this inner box could be what?
View plane and frame buffer?
No. Well, okay. Frame buffer would be the outer box.
Right.
And what sits inside of the frame buffer?
Scene?
No, the scene is over here.
View plane?
No, view plane is this plane here.
Pixel buffer?
Pixel buffer sits between these. It's an abstract idea. No, what sits inside of the frame buffer?
Oh, view.
Viewport.
Viewport. Yes.
That's right.
Which says that you only render in, you render in a sub rectangle of the frame buffer. Okay, so the viewport sits inside of the frame buffer. Okay, so you could say that we have three rectangles. It's a simple model. Source rectangle, which is over here. The destination rectangle would be the viewport, and the viewport sits inside of a frame buffer. Yeah, and yeah, I wish, yeah, here he called the outer window the screen. That's this whole thing. And then he thinks of this as the graphics window, which would be like this. But in our case, it really is more, think of this as the frame buffer, but you can render in just a part of the frame buffer using the, and that's how I do the letterboxing. The examples that do letterboxing, I do it with a viewport inside of a frame buffer. That's how the letterboxing examples work. If you go over here and you look at the letterboxing examples, when this thing letterbox, there's the frame buffer and there's the viewport, and I'm leaving half the frame buffer empty. And then if I change the mode, see, now now the viewport is moved over to this side of the frame buffer, and I'm leaving this empty. Now the viewport sits in the middle of the frame buffer. There's a little bit of unused frame buffer here and a little bit of unused frame buffer here. So my destination rectangle is the viewport, which I can move around inside the frame buffer. So in a sense, I really have three rectangles to work with. I have the image plane rectangle, and then over here, I have the frame buffer rectangle, which the user controls, and then I control the viewport in the frame buffer. So here I can make my viewport maximal. See, I'm making the viewport grow to fit from the top to bottom, but I don't distort, so it can't grow farther than that. So it can't grow any more than that to keep the aspect ratio the same. Okay, right? So here but I'm using the viewport within the frame buffer. Okay, so thinking in terms of rectangles and aspect ratios, and rectangles sitting inside of rectangles, and like here, I'm trying to fit this source rectangle inside of a destination rectangle somehow. I might chop things off. I might, like here, I'm not, here I don't use that part, and I don't use that part. Excuse me. Here I don't use this, and I don't use this. Here I crop off that, and I crop off that. Here I crop off that, and here I crop off that. and you even here, what's paint doing?
Cropping with scrolling.
Cropping with scrolling. Yeah. The source is my picture. The destination is this little window that I'm working with. Notice it's not doing any scaling. It doesn't want to change the size of my picture. It doesn't want to rescale my picture because that'd be confusing to me. If I'm painting a picture and it's changing size, I don't know what I'm painting. So a paint program is not going to want to use scaling because that would be confusing. So there's no scaling. It's cropping. And it gives me scroll bars. Okay, crop with scroll bars, no scaling, to solve the problem of what happens when the source doesn't match the destination. Oh, and what does it do when I get big? Now what's it doing? This is cropping. This is what?
Letterboxing.
Pardon me?
Letterboxing.
Letterboxing. See, it doesn't scale, so it just says, oh, I won't use this part of the window and I won't use that part of the window. So it switched modes from cropping to letterboxing because it doesn't want to scale my picture. It doesn't want to scale my picture because I'm drawing the picture and I want to know what I'm drawing. If it's gonna scale this picture to fill up the screen, I'll have a hard time knowing am I drawing a circle or if I'm drawing an oval. So paint programs almost never scale. They'll usually letterbox or crop. Okay, letterbox or crop. And and then you get things like a text editor where it does what you tell it to do. Crop or distort. Notice that when you distort, it gets hard to read. I really think of that as distorting. Now, from the text editor's point of view, it's flowing the text. Oh, notice that when I flow the text, I lose, see this scroll bar? It's there. When I flow the text, it goes away because it's not needed anymore. Because now it flows the text to that width. I still need the vertical scroll bar, but
I was just gonna say it keeps the index numbers correctly though, or the line number.
Yeah, see how the line, but notice how it skips line numbers?
Yeah,
it's actually real important. If you don't pay attention, you could misread line numbers. See, where's line 18 end? That's not line 19. That's not line 20. That's line 19. Because what's happening here?
it's crunching the one line into multiple lines.
Yeah, it's a form of distortion. See, think of it. It's a form of distortion. It's distorted one line of text into 3 lines of text. So to me, that's a very analogous to the distortion, a circle becoming an ellipse. And if you looked at the code, you'd probably say, yeah, that looks a little bit like what happens when you distort things in graphics. Okay, yeah, you're doing a strategy of distorting to make things fit in that new destination window. You're distorting the original text. Now, if I turn off the flow, there's no distortion. Okay. Line 18 is line 18, but I have to scroll across to see it. See, line 18 is line 18, but now line 18 is multiple lines. And I've seen students get goofed up on this kind of stuff. They tell me, look at line blah, blah, blah. And like some editors will renumber these lines. Not too many, but some will do something dumb. Like they'll renumber these lines and do 18, 19, 20. That's not helpful. But a good editor will not renumber the lines when it reflows the text. But some do. Some get kind of flaky. Okay. So you have these ideas, crop, distort, letterbox. Now, there's no notion of letterboxing that I can think of in a text editor. I can't think of a text editor that would use anything analogous to letterboxing. It's either cropping or flowing. It's either cropping or distorting. It's either cropping or distorting. And same with the browser. When here it's, oh, what's the browser doing now? I thought, that's weird. What's the browser doing now?
Cropping.
Cropping. But a minute ago it was doing flowing. Let's see, go to my website. Now what's the browser doing?
Flowing.
Okay, why is it flow here and crop here?
CSS is different on each
Yeah,
page?
I wrote my CSS one way for my page, and Google is using a different CSS for its Google results. I didn't even never notice that. They're using a CSS over here that causes cropping. I think that's kind of weird. That means that they didn't like the reflowing of that means that they didn't like the idea of reflowing their Google results. Okay, so now what do? They do cropping with a scroll bar. So they do that by, notice the browser doesn't care. The browser lets the CSS decide what to do. So the browser will obey the rules of CSS. Now that's a little bit like what my programs. Okay, if you think about this code here, like this thing versus this thing, well, what does a 3D renderer do? Whatever you program it to do. 3D renderers do only what you tell them to do. So my code says scroll and crop, but over here, letterbox. It's my code that does that. In a browser, it's the CSS. You write the CSS. You write the CSS that says crop, or you write the CSS that says flow. Okay? You do it you choose which behavior, crop or flow. Okay, this is kind of a distorting thing. This is changing the shape of the paragraphs. The disadvantage here is, oops. If somebody does that, notice, see, I did something good here. I tried to design my page using what I think are good typographical rules. So look what happens. What do I do here? My CSS does what? There's flowing. See, it's flowing, flowing, flowing. But what happens at some point?
Letterbox.
Letterbox. Yeah, I switched to letterbox. What was my motivation for switching from flowing to letterbox?
You don't want to stretch the words on the screen.
Yeah, because that's bad typography. I don't want somebody to get a line of text that stretches from the left edge of the screen to the right edge of the screen. That's crazy. Yeah, and so I switch from a distorting process to a letterboxing process. Okay? Google switches from a cropping process to I think they also go to a letterboxing. No, I don't know. I don't know. I mean, they may not even be letterboxing it. They might, I don't know, if your screen is super wide, they may just keep expanding to the width of your screen. Yeah, I don't actually, it's hard to tell. See, now they're scrunching it.
I think they do letterboxing because that box on the right doesn't go full width.
Yeah, so if I had a really wide monitor, I probably would not see this page stretch all the way across the page. You will sometimes find websites, I think Wikipedia is like that. I think Wikipedia, I think if you have a really widescreen monitor, this just keeps getting wider and wider and wider. I have a feeling that they don't really have good design here. I think this thing just keeps expanding horizontally. So I don't know if anybody's got a super wide monitor at home, but like it shouldn't even be this wide. This is kind of nuts. Trying to read this is not really helpful. A lot of times, if you want to read something like this, you're forced to like take your window and do this to make it readable, so that your eyes aren't trying to go, trying to swing from left to right, left to right, left to right. I mean, this drives typographers nuts, this kind of a layout. But I think this thing just keeps expanding. If you had a wider screen monitor, I think this would just keep expanding. So but notice how the strategies we're talking about show up everywhere. Letterbox, crop, scroll, distort. You're always doing the same thing. You've got some source trying to be sent to some destination. You've got a rectangular, and it's all about, even the browsers. Remember, like, because of the box model, because of the CSS box model, everything is a rectangle. Okay, everything is treated as even text is always sitting in a little rectangular paragraph. Text always sits in a rectangular paragraph. So even text is a rectangle. Every letter is itself a little rectangle. Every word is a rectangle. The letters in a word form a little box that is the box of the word. Then the words next to each other form a box that's a sentence. The box model extends everything from a letter all the way up to the whole page. Everything is a box. So you're trying to map rectangles to rectangles. But the rectangles have different aspect ratios. So what do you do when a rectangle that's the source has one aspect ratio and the rectangle that's the destination has a different rectangle? Okay, choices, scale, don't scale, crop, letterbox, distort. Okay, so those strategies are going to keep appearing over and over again. Okay, so graphics, 3D graphics is kind of like a good place to see an idea like this coming up over and over again. You know, graphics is a kind of nice place to motivate this idea of this box model. You know, this model. Pardon me? Sorry. Yeah. But the 3D graphics is, yeah, 3D graphics is a good place to motivate this idea that's ubiquitous all around us. You know, it's everything. It's everywhere where you have to display information on a screen, because a screen is inherently a box. Okay, a screen is inherently a box, so you're just somehow going to be putting boxes inside of boxes, and the boxes don't have to have, you know, somebody has control over the aspect ratio of the destination. Yeah, it, you know, it could be a cell phone, a tablet, a computer screen. It could be a window that someone's resizing. Yeah. So the destination could be your cell phone. The destination could be a laptop. The destination could be a tablet. The destination could be a screen on. Notice that cell phones don't have windows. So when the destination's a cell phone, it's the whole screen always. We haven't got yet to the point where we allow you to have windows inside of a cell phone app. But on a desktop, the target is not the desktop, it's the window in the desktop. But when the destination is a cell phone, it's the whole screen. So you just keep thinking in terms of somebody trying to map rectangles to rectangles. Okay, well, what we didn't do today, I meant to, was to look at the code for actually, like, you know, this idea is actually, it's really good to, I mean, all these different ways of thinking about this is good, but we haven't still looked at the actual code that the renderer uses to do this game. You know, what does the renderer actually do to, you know, how does the renderer map these things? So maybe on Thursday we'll look real quickly at what the idea that the renderer uses to go from here to here. There's a certain idea in the render to go from this source rectangle to this destination rectangle. When we, you know, the source rectangle could have one aspect ratio, the destination rectangle could have a different aspect ratio. What is it the render is really doing, you know, when these guys don't agree? Okay, so we'll look at that on Thursday, okay, because we ran out of time. So I'll go ahead and stop sharing. Okay, and okay, so we'll finish the stuff on aspect ratios by looking on Thursday at exactly what the renderer does to do this. Okay, so see you on Thursday then. Bye-bye.